I've got the law of sines stated up here and a triangle that it applies to down below. Please go through the exercise that's in your book and to prove that this is correct. And if you'd like to see where it comes from, by all means. But we're just going to focus here on how it gets used. So let's kind of analyze what it looks like. So we take the side A and divide it by the sine of the angle A. Remember, when you have a side and an angle, we use the capital letter for the angle and a lowercase letter for the side that's across from it, right? So the capital B is here. That means across from it is the lowercase b, and this is capital C. The side across from it is lowercase c. So yeah, if we take each side and divide it by the sine of its corresponding angle, then we see that in a triangle they're all equal. And we're going to use this relationship to help us solve for sides and angles of triangles that are not right angles. We can see that this is now an exception to what we've been seeing before. This is not a right angle triangle. I did not put a little square down here. It's not 90 degrees. So this law of sines that we're about to see works for all kinds of triangles, so it's very applicable. So let's dig into how it gets used. So in this example, I've copied over the equation, the general equation, and just kind of the skeleton triangle that equation corresponds to. And we're going to use that. I'm going to use a very similar looking triangle for the first one here as we look to measure the length of side C. So this side is our unknown, is C. Now, we could find this angle up here. I know that's kind of tempting to do. We've got 110 and 40. If you really want, that's 30 degrees. You could put it up there. But we don't need that. We're not interested in it. We'll pass over that for now, even though some people may be tempted to go that route. But let's just look at the sides that we do have in here. It looks like we're dealing with, if I kept the letters the same, which I'll do for the first example, that would make this angle here angle capital C. This angle over here is capital A. The 12 is lowercase a, that's side A. And we're looking for side C, lowercase c. So when we look at our formula, our generic formula that we have up here, we don't know B, we don't want to know B, so the middle part of this equation, I'll just rewrite it, but I'm going to rewrite it without that center part filled in. There's not many equations that we can actually do anything useful with where we have two equal signs. So if we rewrite it, we'll have, let's see, little a over sine A. I'll fill it in a moment, but for now I'll just write it blank. And then equals little c over sine of C. Okay, now let's start filling in what we know. Right? When in doubt, just fill in the letters and variables that we know what they are. So little a is 12, so we'll rewrite. I'll move this up a bit. So little a is 12, so we'll rewrite it as 12 over sine of theta. Oh, sorry, sine of theta. That should have been sine of A, my apologies. Should have been sine of A there. The sine of A, well, A is 40 degrees over here, so it's the sine of 40 degrees. And that equals little c. Well, we don't know little c. We want to know it, but it's our unknown over here. So we'll do little c over sine of big C. Big C is the angle C, that's 110. And now this is what we have. Now, instead of, some people here are tempted to just start working all of this out, and I think maybe the book does that too, but I like to run everything in on the calculator around the same time. So when I want to get C by itself, sine of 110, well, that's just a number, isn't it? It's just 0 point something, or maybe negative 0 point something. Either way, the sine of 110 is just a number. So when we solve for C, all we're going to do to get rid of that division by that number is to multiply by that number. So we're going to multiply both sides by the sine of 110. So what that looks like is we'll have sine of 110 degrees times 12 over the sine of 40 degrees. That's how we're going to find little c. That's how we're going to find lowercase c. So we're going to have to take, and now at this point here, let's run everything in on the calculator at one time. So we're going to do the 110, sine of 110 times 12, and then we're going to divide it by the sine of 40. And we're going to push all those buttons on our calculator, and when we do, we get a final answer, hopefully, if you're in degrees, of 17, I'll go to one decimal place, 0.5, whatever the units are. I didn't specify the units. If they were centimeters, then you would put, of course, centimeters here. Now, one thing we can kind of do to somewhat check our work is to look at our triangle and say, okay, don't trust the scale, I guess, of the triangle. That's my first thing, is it looks like this is, this C here is probably longer than this side. Don't necessarily trust that. Trust the fact that the larger you make angle C, the larger side C is going to be. Right? Imagine this angle here, it's 110. Imagine if I stretched it out even further. What if I made it 130 or 140 or 150? Right? You can imagine this side and this side spreading further and further apart. And what that would do is it would make this side C even longer. So what we should notice, at least when we look at these to kind of check our work, is to say, okay, the largest angle should have the corresponding side be the largest. So when we see a 40 over here, it should have a side that's across from it that's shorter than what we see with the 110. So with the 110, we see 17.5 across from it, and with the 40, we see a smaller value, a 12. Well, that tends to make sense because, again, if you can imagine making this 110 bigger and these sides spreading out further and further, then that just makes this side that much larger. So there's an example of how we use the law of sines to find a side. So we can use it to find sides. We just got to label our sides, first of all, so that we have, A's and B's and C's or whatever letters are being used in the question. And we got to cut out the part of the law of sines up here that we don't need. Next, we'll look at an example where we use the law of sines to solve for an angle. In this example, we are being asked to find the measure of the angle theta, and that's given up here in the corner. And we're given the side across from theta is 29, and then we've got this other angle and side that are across from each other, 125 degrees and 52. So first thing I'm going to do is I'm going to put some labels on this so that I actually have something to work with so that I can apply it to my law of sines. I'm going to use letters that fall into the law of sines kind of vocabulary. So I'm going to call this this angle over here, angle capital A, and that would mean that the 52 across from it here is lowercase a. Let me write that again. Is lowercase a. Next I'll make theta. I'm just going to rename this side capital B, and that would make the 29 over there lowercase b. Lowercase b. There we go. Okay. The way that we saw the law of sines stated before, we would write it a over sine a equals b over sine b. I'm going to leave out the c over sine c because I don't know c. I don't care to know anything about c. Now, this is the way it's traditionally stated, and this is the way that we can always start this process. But since I'm looking now for angle B, right? B is my theta, so in a way I've kind of changed my question. Find the measure of angle B. If I want to find B, right away I'm going to be in a predicament here. It's a bit of a tough spot because the B is on the denominator. And one trick that we can do just to get b up on the numerator immediately is to flip both sides of the fraction, both sides of the equation, flip both fractions. So sine a over little a equals sine b over little b. That gives us the exact same result. Kind of a little trick of algebra, right? Remember, whatever you do to one side, you do the same to the other. Well, don't use this too unjudiciously. You got to kind of be careful where you use this. But in this case here, we can flip both of those fractions, and this makes it a little bit easier to work with because now we've got at least the sine b on the numerator. So my recommendation is that when you're solving for an angle, use this form of the law of sines. Use the form where your sines are on top. That way you don't, it just makes it easier to rearrange. Okay, now let's plug our numbers in. So sine of A, we're going to replace that capital A with 125 degrees. Little a is 52. And then sine of big B, well, we don't know big B, right? That's the whole point of this question, is we want to find B. And then little b we said was, what is it, 29 up there in the corner. Okay, now to get sine of b by itself, right now we're dividing by 29, so we would do the opposite. We would multiply both sides by 29. So we'll get 29 times sine of 125 over 52. And that's going to be equal, not to b, but the sine of b. So we got to make sure that when we approach this question, we need to take 29 times sine of 125, divide it by 52, and that, we're not done yet, that is then going to have to be sine inverse, right? Because remember, to get the b out of here, we need to sine inverse both sides. So when you press all of these buttons in on the calculator here, I'm going to write that out to 3 digits. You're going to get 0.4568, so I'm going to call that 7. Now keep that number on your calculator, right? I rounded this number, but keep all those digits on your calculator because now you're going to sine inverse that number. And when you do, you sine inverse both sides, you get b equals 27.2 degrees. And remember, like I said a while ago, we can take this and kind of check our work somewhat by going back up to our triangle. I try to slide that up. All right, so if we look back at our triangle up here, oh goodness, everything's going everywhere. Okay, if we slide back to our triangle here, to say that that was 27.2 degrees, remember the smaller side is going to go with the smaller angle and the larger angle with the larger side. So we can at least assume, yeah, if this angle, we would expect it to be smaller than the 125, certainly based on the picture, but don't go by the picture. Go by the fact that it's 29 over here and 52 over here. 52 will go with the larger angle, 29 with the smaller one. So 27.2, yeah, that seems to make sense. Seems like a pretty reasonable answer. And so now we have the law of sines that we can now use for any angles that are not right triangles, like this one here. And we can use it to solve for a side, either the A, B, or C, lowercase a, b, c, or an angle, sine A, sine B, sine C, for the uppercase A, B, Cs. Remember, if you're solving for a side, it's easier to use this form of it. And if you're solving for one of the angles, it's easier to use this form of it.